Welcome to the second Chem 11 review video for the Chemistry 12 course. This review is on molarity. At the end of Chemistry 11, the last unit you learned was the solubility unit, and in that unit you learned a little bit about how molarity works. I'm going to start here. What is molarity a measure of? Molarity is a measure of concentration. Concentration is basically how much of one thing is in another thing. And more commonly, especially in Chem 11 and 12, is when you're dissolving something in water, how much of it is in the water. So that's what molarity is a measure of. So molarity can be defined mathematically as moles of solute divided by liters of solution. Now the solute is something that you put into water. So it's how much of something that you put into liters of water, basically, is what it comes down to. So the units are mole per liter, which is the same thing as molarity, big M. Remember, moles is just how much of something you have. Just like a dozen is 12, a mole is 6.02 times 10 to the 23 of something. Now in triangle form, the equation looks like this. Molarity, big M, is a measure of moles of solute per liter of solution. Equation triangles are quite advantageous because they give you all three forms of the equation. For example, molarity is moles divided by liters. If you needed to find liters, it would be moles divided by molarity. And if you wanted to find moles of solute in a problem, it would be molarity times liters, because they're on the same level. You would multiply. Let's take a brief look at molarity with a bit of a visual. Right now I just have some water in this container and I can sprinkle some drink mix in. So if I just sprinkle a little bit of drink mix in, I can measure the molarity. It's how many moles of drink mix I put in per liter of solution. And right now the molarity is 0.310. Watch what happens as I put more drink mix in. Watch the molarity. As I put more drink mix in, the molarity increases because now there's more moles of solute per liter of solution, and that continues. Now if I put more water in, what I'm doing is I'm diluting my solution now. So if we go back to our equation, at first by adding more drink mix, I was increasing my moles of solute. Well, if you increase the numerator in a fraction, it's going to make the whole fraction increase. Then when I added water, I was actually increasing the denominator. Well, when you increase the denominator for a fraction, you actually make the whole fraction smaller. Thus, you can see that as I add more water, watch the molarity, it goes down because I'm now diluting my solution. What we're going to do is just practice a couple problems that involve molarity, and we'll be using the molarity triangle to help us. So I'm going to write the molarity triangle on the side here. Molarity is moles of solute per liter of solution. Number one, what is the molarity of a solution made by dissolving 2.45 moles of potassium nitrate in 1.50 liters of solution? So if I want to find the molarity, it's simply moles of solute, which is potassium nitrate, divided by liters of solution, which is 1.50. I have 3 sig figs on top. I have 3 sig figs on the bottom. And when I divide those, I get for an answer 1.63 molar. And that's with 3 sig figs as well. Because when you divide, you go by the least number of sig figs. So 3 sig figs on the top, 3 sig figs on the bottom. That means I get 3 sig figs in my answer. So that's the molarity of that solution. Let's take a look at number 2. You might want to pause it and give it a try on your own. I'm going to start with my molarity triangle. molarity is moles solute per liter of solution. This time I've been given volume and I've been given molarity. Now 400 milliliters, first thing I'm going to do is change that to liters. So to go from milliliters to liters, it's 3 jumps to the left with my decimal. And so I end up with 0.4 liters. Because I had 4 sig figs in my original volume, once I make my unit conversion, I must still have 4 sig figs. Now here we have liters and we have molarity. So if we multiply them together, we will get moles. So moles of NaCl equal the molarity of the NaCl times the liters of solution. And when I multiply those two together, I have 2 sig figs and 4 sig figs. So I only get 2 sig figs in my answer, and it's 0.10 moles of NaCl. Moving on to number 3, you might want to pause and try on your own. So I make my molarity triangle. I'm being asked what is the volume, so I'm going to be asked to find liters. I've been given moles and I've been given molarity. So to get liters, it's going to be moles divided by molarity. So volume in liters is going to be moles of solute divided by the molarity of the solution. 3 sig figs on the top, 3 sig figs on the bottom. I just simply have to divide. And the answer is 0.278 liters. Now if I wanted to change that to milliliters, I don't have to, but if I wanted to, it's 3 jumps to the right. So it would be 278 milliliters. So not quite a can of soda, it'd be a little smaller than a can of soda. And you might want to pause and try number 4 on your own first. Here's my molarity triangle. Now I just want to flip back a little bit. On the very bottom back here, sorry about that, what do square brackets mean? Square brackets mean concentration. So when I see this in writing, what I think about is, what is the concentration of NO3 minus? Okay, what is the concentration of NO3 minus? Now, the most basic unit for concentration is molarity, so I can also think this is saying the molarity of nitrate. So going back to question 4. Get rid of that. It says find the concentration of NaOH, meaning find the molarity of NaOH when 0.32 moles of NaOH is dissolved in 5.00 times 10 to the 2 milliliters of solution. So we're being asked to find molarity. We're being given moles and liters. Liters are being given in milliliters first off, so let's change milliliters to liters. First thing is I have scientific notation, so this 2 is telling me to jump my decimal 2 spots. So 5.00 times 10 to the 2 milliliters is the same as 500 milliliters, but these are all sig figs because it was written in scientific notation. So these are all sig figs. So now I got to jump my decimal 3 jumps to the left to get it into liters. And so there is my volume in liters. So to get my concentration of NaOH, it's moles divided by liters. I have 2 sig figs on top and 3 sig figs on the bottom. And so my final answer can only have 2 sig figs, and the molarity is 0.64. So the concentration of NaOH is 0.64 molar. This concludes this learning section.